Good morning, everyone. On behalf of the Department of Remote Sensing and GIS, Faculty of Geomatics, Sabaragamu University of Sri Lanka and Global GIS Private Limited, I warmly welcome you to the GIS Day 2024 workshop. We are thrilled to have you with us here for a day of learning, networking, and celebrating the power of geographic information systems. Now, we move on to a significant tradition that symbolizes the beginning of enlightenment and prosperity, the lighting of the lamp. This ceremonial act represents the dispelling of darkness and the ushering in of knowledge and wisdom, setting the tone for a successful and illuminating event. To grace this occasion, I kindly invite our distinguished guests to light the oil lamp as we mark the official commencement of GIS Day 2024. I would like to cordially invite our chief guest, Dr. Chaminda Basnayaka, Principal Engineer, Market Development, Locata Corporation Private Limited, Dr. H. Diviture, the Dean, Faculty of Geomatics of Sabaragamu University of Sri Lanka, Mr. Nisanka D. Silva, the Managing Director of Global GIS Private Limited, Mr. Suranga Navaratna, Director of Global GIS Private Limited, Dr. Sankha N. Pereira, Head of Department of Remote Sensing and GIS, Professor H.M.I. Prasanna, Professor in Department of Surveying and Geodesy, Professor Saman Koswata, Professor in GIS in Department of Remote Sensing and GIS, and also two participants for this World GIS Day celebration today. Mrs. J.S. Jaikodi, Senior Lecturer in Department of Remote Sensing and GIS, Professor P.G.R. N.I. Pusalla, Professor in GIS, Department of Remote Sensing and GIS, two GIS undergraduate students of Faculty of Geomatics to enlighten this occasion. Thank you very much. To formally commence the occasion and to extend a warm welcome to our distinguished audience, it is my privilege to invite Professor Saman Koswata, Chair of the GIS Day 2024, to address the gathering.
Very good morning to you all. My dear Dr. H. Diviture, Dean Faculty of Geomatics, Dr. G.S.N. Pereira, Head Department of Remote Sensing and GIS, our esteemed keynote speaker, Dr. Chamith Vasnayaka, Principal Engineer, Market Development of Locata Corporation Private Limited, USA, Mr. Nishanka De Silva, Managing Director, Global GIS Private Limited, and his team, all staff members of the Faculty of Geomatics, all invitees from diverse industries as participants, and my dear students. It is my pleasure to welcome you all to our celebration of World GIS Day 2024, a special occasion that brings all of us together to explore the fascinating world of geographic information systems. GIS has transformed the way we understand our planet, enabling us to visualize, analyze, and interpret spatial data in ways that are unimaginable just a few decades ago. Whether it's mapping disaster response strategies, planning urban infrastructures, or monitoring environmental changes, GIS empowers us to solve real-world problems with precision and creativity. Today, we are honored to have all incredible mix of participants, from aspiring students eager to learn to seasoned professionals shaping the future of this GIS industry. This dynamic exchange of ideas and experience is what makes the World GIS Day celebrations event very special. Our theme for this event, Mapping Minds, Shaping the World, reflects the spirit of innovation that drives our GIS community. Over the course of this program, we will have engaging sessions, inspiring speeches, cutting-edge technology demonstrations, and thought-provoking discussions. We are particularly privileged to have us Dr. Chamith Vasnayaka, Principal Engineer of Locata Corporation Private Limited, who will be sharing insights on evaluation of GIS, evaluation of technology, and the importance of continuous education with a GNSS perspective. Additionally, Dr. Sanka Pereira will deliver a presentation on LiDAR for GIS. Ms. Nishamani Tarunika will discuss integrating GNSS with GIS, revolutionizing industry practices in Sri Lanka. And Mr. Sanchita Vitarna will present innovative GIS applications, case studies by Global GIS Private Limited. And I will present modern GIS applications. I must especially thank to our sole sponsor, Global GIS Private Limited, for their financial support and collaboration, which enriches the learning experience of our participants and brings cutting-edge technology to this platform. We deeply appreciate your tremendous support in not only sponsoring this event, but also taking on most of the organizing responsibilities. Thank you. To our students, I encourage you to make the most of this day, ask questions, network, and let your curiosity guide you. GIS is not a tool, it's a gateway to endless possibilities. And today is the perfect time to dive deeper into this incredible field. Before we begin, I would like to thank the organizing team for their hard work and dedication in bringing this event to life. Let's make today an inspiring and memorable experience for all. Without further delay, let us kick off the celebrations, wishing you a productive and enjoyable GIS Day 2024. Thank you very much.
Thank you, Professor Koswata, for your warm words and inspiring vision for GIS Day 2024. It is with great honor that I now invite Dr. H. Diviture, the Dean of the Faculty of Geomatics, Sabaragamu University of Sri Lanka, to share his expertise with the gathering.
Very good morning to you all. Dr. Chaminde, you're all warmly welcome to the event, and Nishanka to organizing the event. Thank you. And also Professor Pussalla and the team of Department of Remote Sensing and GIS. Thank you very much for organizing the event. Distinguished guests, faculty and students, colleagues and my dear friends. As a Dean of the Faculty of Geomatics, Sabaragamu University of Sri Lanka, it is my great pleasure and honor to welcome you all to this year's celebration of World GIS Day, organizing by the Department of Remote Sensing and GIS, Faculty of Geomatics, Sabaragamu University. Today we gather not just to recognize the power of geoinformation systems, but also to celebrate the transformative role it plays in understanding and improving the world we live in. World GIS Day is a moment to reflect on the remarkable ways of geospatial technologies have advanced our ability to visualize, analyze, and interpret the complexities of our planet. From tracking climate change and responding to natural disasters to optimizing urban planning and supporting sustainable development goals. GIS serves as an indispensable tool that transcends disciplines and industries. It is indeed the language of geography in the digital age. As a Faculty of Geomatics, our mission has always been to push the boundaries of knowledge and innovative in geospatial science. Though our teaching, research and partnerships, we strive to equip our students, researchers with the skills, tools and vision to tackle the pressing challenges of our time. This year, GIS Day comes with an even greater sense of urgency. As our world faces challenges such as urbanization, resource depletion, and climate change, GIS emerges not for only as a solution, but as a bridge that connects in science, policy, and community actions. By saying that, to commemorate the event of this Global GIS Day, I warmly welcome to you all as a Faculty of Geomatics, as the Dean of the Faculty. Thank you.
Thank you very much, sir. We are truly grateful for your inspiring and insightful words. We are now moving on to a very special event of the program. We are now moving on to a very special event of the program, the keynote address. We are honored to have with us our keynote speaker, Dr. Chaminda Basnayaka, the Principal Engineer of Market Development Lokata Corporation Private Limited. Dr. Chaminda Basnayaka is a Principal Engineer with Lokata Corporation, where he is responsible for taking the Lokata technology to new markets for seamless machine automation, autonomous driving, and asset tracking. Prior to that, he was a senior engineer with General Motors R&D and GM on Star, where he served as the GPS GNSS subject matter expert for GM and the US Automotive OEM Collaboration Crash Avoidance Metrics Partnership Consortium. He has authored and co-authored over 20 GM patents and numerous publications and presentations on GNSS, connected vehicles, and telematics systems. His career highlights include winning GM's highest award for excellence and being nominated as one of the 50 leaders to watch in the GNSS industry by the GPS World magazine. So I respectfully invite Dr. Chaminda Besnayaka to address the gathering.
Good morning to you all. Welcome to the GIS Day 2024, and thank you for the introduction. Would like to thank Professor Koswatha, the faculty, staff members, the students and the sponsors, and everybody here for inviting me over. Pleasure to be here. So we'll get on with my discussion here. Presentation. So when I was thinking about what to present today, I was thinking about how fast the technology evolves and how important it is for students and everybody to keep up with that changing technology. So then I thought I might as well talk about my career, how I navigated through the transition of different technologies. Yeah. switch करना है, switch करें, हमें क्या एड्रेस करना है? All right, so I'm going to talk about the evolution of technology and the importance of continuous education, and I'm going to use myself, my career as an example for how you adapt to new technologies and move with the industry. So you may feel like it's kind of a myself discussion, but I'll try to capture the highlights of my career and then the technical changes that I've gone through over time. Now, if you have any questions and comments, please interrupt me, raise your hand and ask questions, no problem. I would like it to be an interactive session, not just a presentation. So I started my career as an undergraduate at the University of Moratuwa, focused on ITS, Intelligent Transportation Systems. This was in the early 2000s. ITS, as you know, is all about bringing communications and location technologies to improve safety and convenience of transportation systems. So that's how I started out. And then at one point, I realized to do all of that, you need to know the location of vehicles and assets and things. So that's how I got into GPS. So the professors I was working with at the University of Moratuwa, Professor Amal Kumarage and Saman Bandar at the time, they found me an opportunity to go and study at the University of Calgary in Canada. At the time, it was it was ranked among the top 3 programs in the world for geomatics engineering. There were some professors who were world famous with written books and so on. So I got the opportunity to go there and study on GPS, and my focus was using it for ITS applications. And to do that, you need to improve the accuracy and reliability of GPS. So that was part of my studies. And I was talking about this to Professor Koswatha and others. At the time of my graduation, the University of Moratuwa had 1 GPS receiver, and we were not able to even touch it. It was in a glass box, and I saw it from outside, and it was inside the glass box. And those are the things that we should change in now. Like, we should have more accessibility, and students should be able to experience these things, and I'll talk about some of that in the slides coming up. So after I finished my PhD, I got the opportunity to work for General Motors. As you probably know, they make Chevrolet, and a few other car brands. In Sri Lanka, they call it Chevrolet. if you remember the name. So I was the GP expert for them. It's one of the big 3 companies. At the time, they made about 5 to 6 million cars worldwide, made and sold that many cars around the world. So my job was to, again, work on GPS and GNSS and vehicle navigation systems to improve the performance of the systems. And also, part of my job was to look at technologies that would work indoors, for instance, inside assembly lines, assembly plants, or in what we call urban canyons, underground parking lots, things like that. So that was part of my job as well. So that got me into searching for alternative technologies. So among the technologies I came across was this company called Locata, a small company from Australia that had a very unique technology that was able to deliver very precise positioning and timing in any space pretty much. So in 2017, I joined that company. So that's how I got into this complementary backup GPS technologies. So now I will talk about this later on. We work on automation, machine automation mostly. Even the US Army, who's maintaining the GPS system, they use our system as a reference when they jam GPS. So I'm truly honored to be working for a company like that and be able to do all of that. And the education system in Sri Lanka actually prepared me for that. So I'm very grateful to my country for that. So a little bit about the company. Can we switch to? Yeah. So as I said, General Motors, they manufacture a number of brands, which include Chevrolet, Cadillac, GMC, and Opel, and others. They also manufactured Hummer at one point, but that was sold to a Chinese company. It's based in Detroit, Michigan. The building that you see over there is their headquarters. Used to work there for about 5 years out of my career. So this is one of the early days. So all the GM cars had this system called OnStar. It's essentially a GPS receiver and a cell phone in a car. So if the car is involved in an accident, for example, it'll automatically generate a message to a command center and then send it out to a command center and say, this car was traveling at this speed, this many people in the car, and then it experienced a collision, for example, of so many G's, G forces. And then that would enable people in a command center to call for help, send fire departments and so on, ambulances and so on. So this was standard across their cars. So our job was to make sure that even if a car is in a tunnel, to get the best location possible out of that car, because you want to send the people to help to the right location, right? So this is one of the systems from the early times. I just wanted to show that because nowadays this is kind of standard in most cars. Any questions so far? No. Okay. So we also worked on autonomous vehicles. Nowadays you hear about Tesla and other cars that drive by themselves. But back in the day, this is in 2011, autonomous driving was a new thing. So I was part of the team that developed this car. This is a fully autonomous truck or a vehicle that would drive in this, what they call an urban challenge. So the US military actually organized it and funded it. So they would give a task. So you leave from point A, go to point B, pick up something, go to another place, do some tasks, and come back, fully autonomous. Nobody can directly get in the vehicle and do anything. So you can see the back of the car, how much equipment we had, and all the sensors. We used to call them coffee makers. Those are LiDAR sensors. At the time they were big, but nowadays they are very small. So I just wanted to show where things started, how it was years ago. We also worked on a lot of other sensors. So there's wheel speed sensors, steering wheel sensors. All the cars have some form of these sensors. We can sense how many rotations they're going through, what the angle of the steering wheel is, what the inertial sensors are doing. So inertial sensors essentially measure the rate of change of heading, acceleration, and things like that. So I know this is a GIS forum, but I think to do GIS you need the location information, right? So that's That's why I thought this will be an interesting topic to you. So going back to the discussion, it's not just GPS, it's a combined solution. We look at all the sensors and try to get the best information possible from the whole system. So the automotive industry at the time had another program called connected vehicles. So connected vehicles was all about, on top of sensors in the car, what if we exchange information between the cars and even traffic lights? So for instance, if the traffic light broadcasts information about how long the red light is going to be for the drive that you are approaching from, then of course in Sri Lanka you'll speed up and try to cross through. A lot of people will try to do that, but so the idea was if the car has automated features, it would either slow down or it will continue to go through the intersection if the light is long enough. And the idea was also to use mobile phones as a part of this network. So you can see the pedestrian crossing the road is connected with cars using this technology. So at the time, this was all based on 5.9 gigahertz. There was a specific frequency band allocated for that. It was called dedicated short-range communications. That's still there. But now the cellular companies are doing this with next-generation cellular technology. The key was, if you use regular cellular networks, the latency, the time it takes from one device to go to the car or back, it takes time. So if you have like apply brakes, it has to be fast, low latency. So the newer generations of cellular technology can do that. So now it's done through DSRC as well as cellular modems. This is a picture with one of our cars. We had a fleet of 5 Cadillacs like this. We used to take them to different demonstrations, intelligent transportation system conference and so on. And we would take people and we will drive behind the car, the front car will stop, and the second car will automatically stop without driver getting involved. We used to show things like that. GPS World magazine that you see at the right side, it's one of the 2 industry magazines, main industry magazines, and I've written a number of articles about connected vehicles at the time, about how things can be done. I was the GPS expert for that consortium. So all the car companies got together and the US government funded these research programs. So the goal was for us to standardize the technology, because all the cars will have to talk the same language, right? It's a common standard. So we were developing things like that, and then we demonstrated those technologies to people. So then in 2017, I joined this company called Locata. So Locata is essentially, we tell customers, you can create your own GPS network-like setup. So left-hand side, that's a picture of a port, a commercial port, and I will show you more pictures of actually operating ports. What we do is we put our transmitters, they're called Locata lights. It's a Locata transmitter, so we call them Locata lights because they work just like a satellite. So we can map out a location and then figure out where we want to put our transmitters. Just like you would track satellites using GPS, our receivers can track signals from our system. So then we enable centimeter level positioning inside any space you want. It could be open. So the White Sands missile range in the US, the military site, they have a very large area, 35 kilometers by 35 kilometers with the system. Ports like this are generally about 3 to 4 kilometers wide and long. We deliver a few centimeter accuracy in the whole area. So we get into the site, map it out, decide where to put the transmitters in, and then we cover the whole port. We do have special technologies. I don't know if you've heard about the thing called multipath. So GPS uses the time of travel. So when you use a receiver, it measures the time it takes for the signal to arrive from the satellite to you. It's a very precise operation. You have to determine that down to picoseconds. We essentially do the same thing. So in an urban environment, if you're not measuring the direct signal from the satellite, if it's reflected from a building or something else, your measurement is wrong. So that can contaminate your solution. So the accuracy you get from a survey equipment depends a lot on what's around you, right? So there's technologies to deal with some of that multipath, like special antennas and things. So we have this special antenna that you see. It's like a basketball. It's meant for heavy machinery, not for small things. But we are working on a smaller version. So we can put one of these on these machines, and they can estimate the position down to centimeter level. We manufacture the whole thing, antennas, receivers, and everything. We are a small company. And the advantage for customers is they don't have to worry about somebody jamming GPS or even multipath, because we have dealt with all of that. So we have a number of ports that are commercially operating right now. Here's an example of one of the ports. We automated Port of Auckland in New Zealand at one point, and now we've almost completed automating the biggest port in the US. So that port has about 150 machines like the one that you see over there, a blue machine, manufactured by a company called Kalmar. So they integrate our technology to their machines. If you look at the top of the machine, you can see the basketball-like antenna. That's our antenna. So these machines, the one on the right, they don't have a driver cabin. It's not meant for a manual operation. Whereas in the left-hand side, you can see in the front of the straddle, these are called straddle carriers because they straddle a container. You can see the manual carrier picking up a white container there. So that machine has a driver cabin in the front of the top. So the driver operates it, picking up and everything. But the blue machine on the other side is fully automated. So from a command center, they say, go pick up container from point A, go and stack them somewhere, or pick it up from a stack in a certain place, put it on a truck. That's all done fully autonomously. It's all digital maps. So they have waypoints mapped out for the port for machine paths, and the machines will negotiate the paths and drive around. So the operation is basically in the left-hand side, the ship would come and dock, and then they have what they call ship-to-show cranes or STS cranes. They go and pick up containers, and then they put it on the pavement. You can see a few of them at the foot of the STS crane. And then these machines go and pick them up, and then go stack them somewhere. So the manual machines can only do up to 3 containers high. The automated ones can do 4, and then they can go much closer. It's fascinating to see these machines going at about 40 kilometers an hour, carrying a container, moving around, and then loading them into trucks and so on. Sleep. Okay, then we go. Now, laptop we got. All right. Okay. Sorry. All right. Yeah. So this is another picture of a straddle carrier with. So right-hand side, you can see how we mount our transmitters. So we pick lampposts and put our antenna, transmitter antennas on them, and then the straddle carriers. They have this particular model has 2 of our antennas. That's what's shown in 2 purple glowing bolts. So the machine has other sensors like radar for object detection and collision avoidance, and then other mechanisms to pick up containers and so on. So we provide our technology to the system integrator to put this together. Any questions so far? Sinhala guna kavanne prashna tiyena nan. Yes. Yeah. So let's see. Apita මේක ඇතුලේ positioning system එකක් දාන්න, we can say, okay, that coordinate is 0, 0. This is 0 something else, and then the receiver will output based on that coordinate system. If you want the global coordinate system like WGS 84, we just have to program the transmitters in that coordinate frame. Whatever we do, it outputs in that frame. And same thing with timing. So we can designate one of our transmitters as the master. Everybody else will follow that. So we can use the same transmit signal for time synchronization. So as you know, with GPS satellites, they use atomic clocks for time synchronization. The whole system will have to be synchronized because it's all based on a clock system, right? So you're measuring your time of transmission. We do the same, but we don't use atomic clocks. Instead, we designate one as a master, and all the other transmitters can listen to that signal and synchronize using the same positioning signal down to picoseconds. So that's why, as we were talking, we can do picosecond level time synchronization over radio frequency. So we are a complete PNT system, not just positioning. We do positioning, navigation, and timing, all three of them. Largest area? It depends. So in the US and everywhere, there's transmission power limits. So FCC, their authority, they have frequency power limits. And we operate just like a Wi-Fi device. So with that, we can transmit up to 2 kilometers or so. So if you have like a 2 kilometer box, we can theoretically cover that with 6 transmitters at the edges. But in other places, like the White Sands missile range, it's controlled by the Army, right? So they can put amplifiers, increase the signal. In there, we can track up to 40 kilometers, no problem. So the lights will come in. It's designed for aviation use. So they can come in, and then our receivers are quiet about 40 k's away from the network. And then they come in and fly through the network. We have done that. So we've done things like integration with GPS as well. So let's say you have a car with GPS and locator in it. You can navigate with GPS outside where we don't have coverage. And then once you enter the area, we can combine them. We can combine at position level, or we can do at like measurement level as well. So if you go into theory like least squares measurements, and you can put both measurements in. And we have a Leica product, actually, I was mentioning this to you, for mining. So in deep pit mining, I actually have photos. So that's a diamond mine. So the deeper you go, you cannot see the sky when you're close to the wall. So in that sort of situation, companies who manufacture machines like this, they have problems in positioning their machines. Plus, it's a safety hazard, right? So like these places use explosives to take material and things, so there's earth slips and so on. So they have motivation to automate these machines. So in those places, they put our system and GPS together. So what the receivers do is they pick the best combination of locator transmitters and GPS transmitters, GPS signals, to generate a combined solution. There's a Leica product called JPS, Jigsaw Positioning System, JPS. So that combined both of them. I'm not sure if it's active right now. They may have a different brand name, but there's a combined system. So yeah, just like straddle carriers in ports, this is mining machinery. You can see how big that machine is. I've gotten into one of them, and it's huge. Like the tire itself is twice as high as I am. Imagine a tire that high, right? So it's a huge vehicle, and you can see in that bottom picture, the little dot next to one of the front two trucks is a pickup truck. So you can imagine the size of it. And then they operate like hundreds of machines like this, going up and down, moving material. So we worked with two of the manufacturers of these machines to automate their system as well. They have GPS systems already, but we have helped them to put our transmitters and GPS together for better accuracy for deep pit mining. So that's another application. In theory, that's what's done here. So the combined Yes. Yes. They have number of sensors. So these vehicles have LiDAR, radar, and inertial sensors, very expensive inertial units. And even for our systems, they have two receivers. So they combine, they do they call a lever arm solution. So they know the orientation as well as they can cross-check the accuracy. Same thing with the straddle carrier. The reason they have put two units in one is so that they can cross-check the accuracy between the two, right? Otherwise, there's no way. Like with GPS, you get an accuracy estimate, but that's an estimate, right? You don't know the truth. So therefore, they use dual systems for redundancy, especially in machine automation. If one fails, the machine stops right away if there's any doubt about the integrity of the two systems. And the other thing is, you know the distance between the two units. So that's your redundancy check. So another interesting aspect of this that our company is dealing with and we are deeply involved now is jamming. I don't know if you're familiar with it, but it's very easy to jam GPS. If you remember back when there was a terrorist war in Sri Lanka, I've seen one news bulletin in which they showed GPS jammers and GSM jammers. So I've shown one of them at the right-hand side bottom. That's a GPS jammer. China used to make them. It's very much illegal to use them because you're transmitting in a protected band. But if you plug that in and then power it up, it can potentially jam up to 5 to 10 kilometers. GPS will go away. So this is a problem. Back in like 2005, one of the US airports experienced an outage like this. It took months for them to bring in the Department of Homeland Security, military and others to put tracers along the airport periphery. And eventually they figured out it was a company vehicle. Somebody wanted to take the company vehicle to see his girlfriend. So when he goes there, he would plug one of those into his car and drive around so that the company cannot figure out where the car is. So unintentionally, he jammed GPS at the airport. Eventually, he was found and then he was sent to jail. But that's a problem. So what I'm showing on the left-hand side is now there's services where you can look at areas where GPS is jammed using aircraft and ship data. So anywhere you see red or yellow, that means there's active GPS jamming going on. So that happens a lot around Israel. They intentionally jammed and spoofed GPS, which I'll talk about in the next one. Iran did that. So at government level, as well as individual level, these things happen. So these things came up as early as the year 2000. So the US government first talked about this back in year 2000, that there's vulnerability. This can be jammed, and what happens if it's jammed? So now these governments are looking at alternative technologies actively, which I will talk about in a bit. But if you go to like this site called GPS Jam, you'll be able to see what's happening right now. You can zoom in. And the reason they do this is because if someone's sending you a guided missile, if you jam GPS, if you spoof GPS, you can send it to somewhere else or it will get lost. That's the idea. It's very, very common. Now here's another example. This is spoofing. So it's kind of funny. This is around Israel. So the yellow line, so the blue area there is the ocean, Mediterranean Sea, and then the yellow line is going to Israel. The red line at the top, that's Haifa port, and then further north is Beirut. So what happens here is a ship would come, and then suddenly it would move to the airport in Cairo for no reason. A ship in the sea would show that it's at the airport. Same thing happened from Haifa to Beirut. So this was intentional jamming. When Israel was worried about Iran attacking with guided missiles, they did that. So they had local transmitters that emitted fake signals that would give a fake location. So they programmed it so that the destination is shown as somewhere else. So this actually happened to regular people too. So people would wake up and use their nav system, and then suddenly they're in Tel Aviv, but it shows you in Cairo or in Beirut. So this is high-tech stuff, but it's not that hard to do. The challenge is GPS signals are very weak because they are broadcasted from satellites that are 20,000 kilometers or so away. So it's very easy to jam or fake it. So this is a challenge. And the other thing is that it's everywhere. So like this is a slide I took from a presentation from the Department of Homeland Security in the US, because it nicely captures everything. So power grids, banking nodes. So if GPS goes away, your ATMs will not work, because banks use GPS for timing, to timestamp your transactions. So if GPS goes away, your ATMs will stop. The cellular networks will stop, because time synchronization of cell towers use GPS. That's how they do it. Or you have to put fiber networks to synchronize it. So the governments have realized this in the other parts of the world, and they're looking at alternatives. What if this goes away? In a city, if the communications and banking networks go down, then it stops, right? There's nothing you can do, like everything will stop. And this has happened in places like there was a news article about something happening in Australia where a communication network, cell network went down and people couldn't even use a bus because even the bus ticketing system used the internet. If you can't get onto the internet, you're done. So the European Union had a program where they looked at alternative positioning, PNT systems. That's what I'm showing on the right-hand side. So they called out to the companies who can demonstrate technologies that can back up GPS. This was in year 2021. So we put in a proposal and we were part of that project. So they studied our technology for 2 years in Italy and other places. We set up networks for positioning and timing, showed them how we can back up GPS. So that report is the cover page of that report is what you see there. And there's an equal US program going on. They have what they call a complementary PNT action plan. So they're actively looking at what are the vulnerable services and how can we use the other technologies to bridge those gaps. So I'm actually actively involved. I'm managing that project for our company. We have several sites that we are demonstrating this technology to the Department of Transportation to show how we can back it up. So that's my current work. So finally, I think this sort of continuous education and educating everybody is very important, absolutely important. Industry is very important. Otherwise, you'll be in an isolated space as academia. It's very important to bring in people and educate the professionals, especially to start with. And we have to understand that we are working with systems of systems. What I mean is, take cellular system, right? It's built on GPS. So if the foundational system fails, your other system will fail. So this is what we have to realize. It's a system of complex systems. We have to understand those, and that will only allow us to progress. Vulnerabilities, we have to learn about those as well. And that's why especially I want to talk about this last little bit. We are users, but at the same time, what if something happens? We don't know if it will really happen, but even the US government have said that in an event of war, they reserve the right to switch it off and then let military use the technology and deny civilians from using it. So what happens if that were the case? So it's very important to know those things and then design our systems to be resilient as much as possible. And then collaboration. We have industry and academia here, and maybe even the government, because at policy level, some of these things will have to be defined as well, right? Because we have to set our priorities. So I think it's very important. Finally, not just at the university level, even at school level, we use location, right? Like if I ask for direction to some house, they'll be like, oh, I'll send you my location. Well, how does that happen? Right? We can get school children and others to even use like a smartphone that you have today. You can get some GPS data out of it if we know how to do it, and then do things so that they get interested in this technology and learn. So that's my message, and enjoy your conference. And again, thank you very much for inviting me over. And if you have questions, I'll be happy to take any.
Yes, thank you, Dr. Chaminda. Yes, it is interesting to see that you are trying to simulate the GPS signals or GNSS signals, right?
It's not necessary simulation. We are recreating a signal just like that.
Okay. Anyway, you will find some multipath issues, sort of things. Are you?
Yes.
Okay.
That's why we have that special antenna. Mm-hmm. And for our transmitters, we use 4 signals. So with GPS, there's at least 2, right? L1, L2, and L5. Yeah. Similarly, in the Wi-Fi band, so we operate in 2.4 gigahertz. Mm-hmm. We use the upper edge of that frequency spectrum and the lower edge, and then we use 2 transmitters. So essentially, we have 4 signals coming out of one antenna. So we cross-check them to identify multipath and minimize them.
Okay, really. So I asked that question because we have a couple of researchers. We are trying to use that multipath signal for through the interferometric reflectrometry technique.
Okay.
Right? So I was looking for some solutions with your system.
Right.
So you are doing it in a different way.
In a different way, but at the same time, the antenna that I showed, the spherical antenna, we have 60 patch antennas on it, and we switch them in a certain sequence. So we essentially map the whole area. You know, if you have one transmitter, we look at all the reflections from it by switching to different antennas. We digitally sample the whole space. So we can do radar-like applications, although we don't do it right now. There's other applications. We've only gotten to the PNT part of it.
So anyway, you have a model, you know what are the objects you have, it's clear.
Yes, yes. In theory, we can estimate what other things are reflecting the signal, because we know where the direct signal is, right? The shortest path, and so on. And then we have programmed that into the system, just like GPS almanac or FMRS. We know where our transmitters are, so we can orientate ourselves to figure out where the direct signal is coming from.
Right. Interesting. Thank you.
Yeah, actually the APN is actually future, because we must have a kind of alternative when, you know, what we are going to do, you know, once GPS, we lost the GPS signals. And still actually the APN works for better, as far as I know, that it's better works for navigation, maybe inside the shopping malls or inside the airport. So but still it's challenging for you know, the accurate positioning, because you know depends on, you know, it's not like the high precise signals, you know, inside whether we are using Wi-Fi or cellular signals, or there are certain, you know, the factors that depend the accuracy, like signal strength, like so you know. But US, you know, have you tested any precise that as your experience, what is the best method, you know, so far you practice, you know, or you tested for APN, like you know? You
mean like for indoor positioning?
Yeah, indoor positioning.
The best system I have seen is the system we have.
Yeah. That's what I know. The APN actually needs, because the GPS, when we, what we are going to do in actually, we lost the GPS signals or GNSS or whatever it is.
Right. Well, the challenge is our system is very expensive. It's meant for industrial applications and things like that. We're trying to bring the cost down. In terms of other technologies, there's Wi-Fi signal strength based systems and others.
Yeah.
But they don't, as you said, they're not very accurate. We want to get into like the warehouse positioning space, so we are trying to bring the cost down. We need to find markets in what we do to do like low cost, bring the cost down. That's where we are. Wi-Fi based systems is the only other thing we see. And again, it's very challenging, because when we do indoor demos, we have the challenge of finding a good reference system, right? Because if we are delivering 2 centimeters, we need a system that's more accurate.
Yeah,
there's nothing like that.
Local system.
Local system. We usually use a prism, survey prism on top of our antenna and a total station to track it. That's what
still you have to go back to the conventional.
Go back to the basics. Yeah, like I was just planning yesterday, we are going to do a demo in a gymnasium. And the only thing we can use is a auto tracking total station and a prism. That's the only thing that can do millimeter level positioning.
Thanks, you know, thank you for sharing your knowledge here.
Thanks.
You are telling that you used 2.5 gigahertz band. So is it like I'm asking about Wi-Fi jamming? Are you overcome that issue, or is it still a problem?
It is a problem. Very good question. So the reason we use 2.4 is we don't need a license, right? Any other frequency we need a license. Licenses are very expensive. Like in the US, it will take years to get spectrum. So being a small company, we don't have the resources to buy spectrum. And then even if you buy spectrum in the US, UK or Europe will be a different thing. So we wanted to use 2.4 this is in this phase. So the next generation hardware will have the flexibility to go from 600 megahertz to 5.8 or something like that, even higher. So we have the flexibility. So what we do is we offer the flexibility to the customer. So like if it's a military, right? If they have particular spectrum, we can configure our device to match theirs. With 2.4, we do have challenges. We usually, like, this is in controlled environment. So if we go in a port, we ask them about their Wi-Fi, where the Wi-Fi APs are, and then what channels they are using. So we work with them, and then sometimes we migrate their Wi-Fi network to 5.8, and then we take exclusive access to 2.4. But it's not a huge problem, but if you put an access point right next to our antenna, it's not going to work. So interoperability is an issue because we are in somebody else's space.
Thank you. Another question, like, I have a problem with that. How many channels could you use within your system? Like, how many receivers could you use?
It's unlimited. Ours
for Wi-Fi, it is limited channels, right?
Yes. So our system is designed just like GPS, a passive system. We don't have two-way communication. It's just receive. The signals are very similar to GPS. Yeah, there's no two-way communication. We intentionally did that because otherwise, like you said, the capacity becomes a problem. So we don't have that problem at all.
Thank you.
All right. Thank you very much. Enjoy the rest of the conference, and thank you for inviting me.
Thank you very much, Dr. Chaminda Basnaika, for your inspiring and insightful keynote address. We truly appreciate your time and effort in sharing your expertise with us today. It is my great honor to invite Mr. Nisanka De Silva, the Managing Director of Global GIS Private Limited, the esteemed sponsor of today's workshop, to kindly address the gathering. Your support has been instrumental in making this event possible, and we are eager to hear from you.
Good morning, everyone. It is my honor to be here as the Managing Director of Global GIS Private Limited and main sponsor of this wonderful event, Global World GIS Day 2024. I extend my gratitude to the Department of Remote Sensing and GIS, Faculty of Geomatics, Sabaragamuwa University of Sri Lanka for organizing this wonderful gathering at Diasaru Park, Battarmulla. As we celebrate the theme, Mapping Mind, Shaping the World, it is heartening to see professionals, academics, and students coming together to recognize the transformative power of geographic information system. GIS is not more than just a technology. It is a tool that connects communities, enhances decision making, and drives innovation in a multitude of industries. At Global GIS Private Limited, we are proud to be at the forefront of providing cutting-edge geospatial solutions and survey equipment in Sri Lanka. As the sole agent of TOCNAV GNSS product, we aim to empower surveyors and GIS professionals with tools that push the boundaries of accuracy and efficiency. Sponsoring this event is not just a responsibility, but a privilege. It allows us to contribute the growth of geospatial science in Sri Lanka, fostering collaborations, education, and innovation. As we move forward, let us not just celebrate GIS today, but commit to applying its potential for solving real-world challenges, whether it is urban planning, disaster management, environmental conservation, or building smarter cities. I encourage the young mind here to innovate and professional to mentor the legacy where GIS continues to shape the future in Sri Lanka. Thank you once again to organize for this opportunity. Together, let's map mind, shape the world, and drive Sri Lanka towards a future of geospatial excellence. Enjoy the day event. Let us continue to inspire in the another. Thank you very much.
Thank you very much, sir, for your words. And I kindly request again for a round of applause for Global GIS Private Limited, not only for their sponsorship, but also for their support throughout our work with Faculty of Geomatics. Okay, we now proceed with a much promising event of the program, the session on Industry Talk presented by Global GIS Private Limited, who is also our special partner in the GIS Day 2024. I cordially invite Mr. Sachinta Vitarana, Assistant Manager, Research and Development Division of Global GIS Private Limited, to share his expertise with the gathering.
Good morning, everyone. Chief guest of today's session, actually, I think this is the inaugural session of GIS Days, which is going to happen in future as well. So we are very happy to become a main part of this first ever inaugural session of GIS Day. So thank you for the Faculty of Geomatics for choosing us to be. So chief guest, Dr. Chaminda Basnayaka and Dr. Divture, Dean of Faculty of Geomatics, and Professor Indiga, Professor Koswata, Dr. Sankar, and Professor Pusella, and all the distinguished gentlemen who are here to witness this event. And I cordially welcome you once again. And please enjoy the rest of the day today, since there are lots of things going to happen in coming sessions as well. So enjoy your day today. And for Global GIS, actually, this is our, what we think actually as a company, we think actually this is one of our key responsibilities to enhance and build the sector of geospatial science in Sri Lanka as well as in the entire world. We are not only, focusing ourselves into local aspect, but we are going, rather than pushing our boundaries to different aspects of this geospatial science and make all the people aware about the geospatial science field. So today my topic will be innovative GIS applications. Actually, this is actually my point of view of becoming a survey. Since the introduction of geospatial science field, what I think is that a surveyor or a geomatician is the one who handles the main role of geospatial science field. That's what I think, because main reason is that the entire subject of geospatial science realizes there's no one better than us to analyze and collect, analyze and interpret data to the fullest accurate and precise level. So I think in this session also I'm going to highlight as a geomatician what we can do to elevate the geospatial science field, and I hope you enjoy the rest of the slide. Before going to our technical sessions, I would like to give a brief description about our company, Global GIS Private Limited. And actually our company was established in the year 2014 by none other than Mr. Nishank Zisitla and Mr. Suranga Navaratna. Both are registered licensed surveyors who actively dedicated themselves to elevate the local geospatial science field for the past 10 years. So collaboratively, both of those gentlemen did a lot of work into this field and continue to do so for the future as well. You can see the right side of the slide, my slide. you can see the main functions of our company, and actually one of our main functions is to introduce latest technology to the local community by different kind of equipments from let's say from a small tape to TLS, LiDAR, USV, you might say, whatever the latest technology available in the market, we have already introduced them into the local Sri Lankan market as well, and make the people aware about what are the technologies, what are the data collection methods they can use in order to make more efficient, effective decisions. So our main function is instrument selling and hiring, and we also conduct projects and consultancies, and we do a lot of capacity building programs as we speak, because for the company perspective, we put a lot of efforts to build the capacity of the local community. So far, for the past 10 years, actually, we did more than 1,000 of ARNS programs throughout the entire island, and also in the foreign countries as well. So at the end of the day, our motive will become fully make the people aware about geospatial science field. So, and also we do services and calibration, and also none other than we have a special function in our company, which is the Global GIS course network. And as at this moment, we host the largest course network in the Sri Lankan environment by a single company, operating 32 continuous operating reference stations available, readily give you RTK, real-time RTK positions to enhance your GNSS surveying accuracy. And we are going to expand into 36 stations, and right now also it fully covers the entire island, but due to some technical advancements, we need to expand it to 36 stations, and after that we are fully operational. Right now also we are fully operational, but we are going to expand and use it into, rather than providing RTK accuracy, we are going to use it into different kind of aspects of geospatial science field. So that's what our main motive is when it comes to course network. And you can see that these are our main brands that we are promoting in Sri Lanka. You can see from geospatial to geophysical, laser scanning, hydrography, you name it. When it comes to geospatial science, we are providing almost every solution possible for our end user. So we are very happy to giving our solutions reliable solutions actually, rather than just stereotype solutions which gives you solution for a little bit of small period of time, but we want to build the community for a long period of time and make them aware about what they can do with these technologies. So we are very happy to provide solutions based on these products actually. And as I told you before, this is our course network. As you can see, right now entire 32 stations are fully operational and ready to give you RTK positions at all times. And most of our customers put their trust in this course network because it always provides the reliable solution at all times for anywhere in the Sri Lanka. So that's why most of the people are using this course network to their own benefits. And we are very happy and very privileged to achieve this milestone. Also, because of this and also our technical capacity, we were able to become the largest market shareholder for GNSS technology in Sri Lanka, which comprises more than 75 to 80% of market share. So we are very proud of that, and we continue to elevate these kind of technologies and introduce these kind of technologies to Sri Lankan community. So that's from our side what we do actually. And the main reason that we are very unique when it comes to geospatial science field, and one key aspect of our uniqueness is that we are always providing technical expertise rather than just giving random things. We always try to rightfully cater to the required problem that our customer has and providing reliable solution which is sustainable and efficient one. So for that we continuously technically evaluate ourselves as well as the company standards and mechanisms, and with that we are trying to continue this trend to the future as well. And you can see the second point is that our company has an exceptional talent. I think most of our company staff are almost under 30 years of age. So entire staff actually of our company, more than 60% of our company the background of our company is serving sciences from all the way from top to bottom. So the talent, knowledge, and everything is there. So we collaboratively, when there is a requirement, we collaboratively approach together to resolve that particular problem. So that's why most of our customers are still with us due to this date actually. And culture of collaboration, we continuously keep a good environment within our company from all the way from top to bottom, and putting an effective communication in between the parties who are involved when we are taking decisions. So at the end of the day, whatever the decision we take, it has to be the right one, and it has to be the most efficient and effective one for our user. So that's why we are keeping that environment in our company, and strong engagement. We right now also we are trying to engage ourselves into elevate the geospatial science field in Sri Lanka. So like this we did when it comes to local and international environment. And the final point is that we are always investing ourselves into making ourselves a more successful figure or professional in this industry. So that's what as a company. And these are clientele. Just a couple of clients that we are highly emphasizing and we have strong connection with. And private and clients. And in here, I'm going to show you that we are not just a local company, we are an international company. So have a look at the video, please. Thank you very much. So let's go to the kind of a technical session from our side actually, and what we do to elevate the local geospatial science community in Sri Lanka. Actually we are going to demonstrate or present a couple of 4 case studies we did when it comes to Sri Lanka. So by going through each of them, you can see that what are the things that we can do in this industry and how we can do those things. So let's go to the presentation. And first case study actually. In first case study actually we mainly did this project for one of our clients to establish a floating solar project at Randanigal Reservoir. And you can see the products that we actually use for, to get the final outputs and do the interpretation and final, conclusions and all those things. And Batiloga is the one that we are promoting as the main single beam echo sounder that we are promoting as the company. And Planet is one of the prominent satellite imagery provider in the world. And 3D Survey is also a up and coming most innovative geospatial science company which provides software solutions related to this field. And also ArcGIS Pro, as you all know, the most prominent GIS software in the world. And Civil 3D as a surveyor, almost everyone uses this software on daily basis. And also with the QGIS, similar to ArcGIS Pro, it is also very reliable and effective software when it comes to providing GIS related outputs actually. So when you see the final report, you can see the final prepared reports that we did for our client actually. And you can see that almost every aspect of our project is covered. And you can see the study area of the Randanigal Reservoir did more than 5 to 6 square kilometers of the study area. And all the basic principles were observed and followed throughout the entire process. And we did the bathymetric survey as well as generated the final end for our end user to get the decisions based on that outputs. And for that purpose on area, we cannot fly a drone or something like that. So because of that, we need to find an alternative solution. So for that, we used Planet satellite imagery outputs, and I generated the comprehensive final digital elevation models and all those things for our client in order to take relevant decisions to build the required floating solar power plant. And this is the CAD plan also with the 0.25 meter contour interval. And yeah, these are the equipments that we used, softwares. Yeah, that's one of the first case study that we did. If you have any questions, please don't hesitate to ask. We are ready to help you at all times. And yeah, this will be the first case study. So in this case study, what we are emphasizing is that the integration of GIS for the hydrography for the hydrography and remote sensing applications. So you can see using Planet will be the main remote sensing application that we are used product, and Batiloga and all those things are hydrography products. And integration of remote sensing as well as hydrography outputs and couple them together and get a final decision. We need to have some kind of a GIS analysis and GIS knowledge within ourselves in order to make the final outputs to the most accurate and efficient level. That's what I am trying to emphasize in this slide for our stakeholders and people who are engaging in here. And in the second one, in the second program, in the second one, what we are promoting is that integration of US in floating solar energy. And in here, the previous case, we have used the single beam echo sounder. In here, in this case also, we are still using the single beam echo sounder, but with a different kind of technology. It's what we called unmanned survey vehicle, or USV. And you can see by utilizing the USV technology, we have we did the entire bathymetric survey part to the fullest accurate level, because in most cases, if you have some experiences in bathymetric survey, when we are using, let's say, some kind of a boat or something with a single beam echo sounder, if not your coxswain or whatever the person who navigate the boat don't have any skills, then whatever the survey you do will be little bit of out of accuracy actually. So, but when you are using USVs, it's not the case like that, and very reliable and efficient, provides reliable and efficient outputs at all times, and very time saving equipment, because if you are using suppose that if you are using some kind of a traditional board or something to do the bathymetric survey, it takes at least 7 to 8 days to complete the entire survey work. When it comes to the area of that study area, it was around 4 square kilometers of the Samanala Reservoir. And within 4 days, we have completed the entire task, the entire 4 square kilometer area. And we use these products. CHC now is the US unmanned survey vehicle product. GoSlam, Bathylogger, TalkNow for the GNSS support, and 3D survey for the software integration. We can actually of using 3D surveys to as a surveyor. It provides a lot of user-friendly functions for the geospatial community in order to build final contours, digital elevation models, CAD outputs, GIS outputs likewise. So very user-friendly software right there. If you are interested, you can try it out. And QGIS software, traditional GIS softwares, and Civil 3D as well. So these kind of products that we are already used to make the final outputs in order for our client to take efficient and effective decisions. And if you go to the final report, you can see that the things we did. And yeah, this is some kind of final report that we prepared for our end client, and also a case study for the we use it as a promotional tool. And you can see what are the things that we did. You can see the study area. The entire study area was covered within 4 days, 4 square kilometers, which is almost 75 to 80% of entire reservoir. So we did that. We generated the contours and all those things. And also with the easiness and efficiency of the USV and the other LiDAR products that we have used to get the bank details and all those things, we were able to finish it within the complete work within 6 days. So the client was also very satisfied with the final products and all those things. So that's the second case study that I'm trying to give you some idea about, which is the integration of USV technology, LiDAR technology, and as well as integration of GIS. With the GIS, integration of LiDAR and USV technology for the local community. One other key point is that as the global GIS, we are the first ever company to introduce unmanned survey vehicle technology to Sri Lanka. So we are, in that case also, we feel very proud and honored. And okay, this will be the case study number 2, and a small video for you to have a look. that's a small video for the introduction purposes of that we made for the introduction purpose of unmanned survey vehicle. And next case study. In this case study that we are promoting integration of LiDAR and single beam echo sound for the GIS, and the main products that we use is the same products that we are promoting in here. And the final outputs are already generated, and we give her some kind of insight to our end client that you can do this. You can use LiDAR and hydrography techniques and generate the final output of their main requirement was to build a digital elevation model of the entire river bed, as well as the 100 meters to the both sides of the river center line. And the final output was the data was collected using echo sounders as well as LiDAR equipment, drones and everything. And the final output was generated by utilizing the both data captured by both the technologies, and couple them together or merge them together in order to make the final output, and which is some kind of which is actually most of the time will be a GIS integration. So that's what in this case I'm going to demonstrate to you about. And this is the final kind of a promotional case that we did, report that we prepared. You can see that the objective was to use the equipment and LiDAR technology that we are using in order to promote in here. And the final outputs were generated. You can see. Yeah, that's that actually. And one final case study actually. I don't want to keep you wait for so much time, so let's quickly move on to that final part. And this is the one of the most important application that in here that we are trying to promote actually, integration of geophysical applications to our one actually GIS field and surveying field or geospatial field. Because in here actually from this year onwards we are started to put our hands into geophysical world, and so we partnered with one of the premium brands when it comes to geophysical market in the world called Guideline Geo. Those are the one of the main expertise and main product which the entire world is putting their trust into, especially in GPR and resistivity meters. And all this equipment are helping us to map the subsurface. Subsurface means the surface below the actually Earth's surface. Okay, so in there we are integrated geophysical technologies, geophysical theories, and all those things into our world and map them together to make a final output. I couldn't prepare much for that actually, so I'm just put a presentation. Wait. Which actually we actually published this in the FIG regional conference held in last November, and utilizing LiDAR, UAV LiDAR subsurface geophysical mapping for comprehensive landslide detection, and we presented that at the last FIG conference. And you can see the methodologies and reason behind this that we are using this technology in order to make it make a final output in order to take good decisions. And objective and research problems, methodology and everything is there. Study area is also there, and the final outputs. I hope this is not working properly because there there should be some kind of an animation in order to, see all the final outputs that we have generated from LiDAR as well as using geophysical methods. Sorry for that actually, but if I can show it. I'm not sure I won't be able to show it the entire outputs that basically the entire outputs rise around digital elevation models and roughness, slope, aspect, and contours and everything. So we generated those outputs from LiDAR basically, and the subsurface is mapped using seismic refraction tomography is what we say, used to identify the subsurface velocities. So by using those outputs, we generate one single output. You can see that in next slide. This is the final output of the subsurface. I hope this is working. Yeah, this is working. This is the final output. Based on the velocity, the geophysical equipment provide us the places where the soil is smooth as well as rough. So depending on those outputs, we can identify where the potential of having a future landslide is about. So that's that. And yeah, so the final conclusion. And this is the consultant and all those things. And that's about the presentation we did at FIG regional conference. Yeah, so thank you very much. I hope you have got some kind of insights on what we can do actually as a fellow geospatialer, because especially in geomatics field, personally what I believe is that we can do a lot more rather than doing just some kind of traditional land surveying and stuff, because there are so many aspects and applications are there that we can put our direct hands into, since we are the most important and vital part of maintaining this geospatial industry to the future. So because basically we are talking about coordinates and everything, accuracy and precision of coordinates and everything, how the accuracy and precision comes for that particular coordinate based from geodesy, GIS, remote sensing, and whatever the application that we are using. So we have good expertise on that side. So I urge our fellow geospatialists as well as young talent from Faculty of Geomatics to consider these kind of aspects of geospatial science field. Hope you can make it to the next level, because my personal experience is that for geomatics field and the Faculty of Geomatics have good potential to make it expandable to internationally. Right now also a lot of people who are live and work in other countries have good understanding and good reputation of maintaining good results and outputs when it comes to surveying sciences and geospatial science. So I urge fellow geospatialists to consider about that as well. So thank you very much. I hope you have enjoyed my presentation and get something out of it. So thank you very much.
A heartfelt thank you to Mr. Sachinta Vitarana from Global GIS Private Limited for their informative and engaging industry talk. We truly appreciate your valuable contributions and insights into the field. We will now break for morning refreshments. Please participate for the group photograph and feel free to enjoy, and we will resume again by 11:10 for the upcoming session on applications of LiDAR data. Thank you. please direct to the registration desk for the group photograph.